It's recording again. So we are using u substitution here for solving roots. So we can follow from here, okay? So we substitute u here. So what is this? This here, you can see that this here is dx, okay? This is dx, okay? What you have here in equation, this dx, okay? And here, this dx, you can see it from here. U, we have said that this is u here. We have given the name u. We have given this one the name u. And here, instead of x, we write u to the power 3 plus 2. Okay? So we have all x written as u. And now we have here, this is u to the power 3 plus 3 plus 2. That makes 5 here, u to the power 3 plus 5. But we multiply by 3. So I can write this here for explanation. Just a moment. Now we pass from there to there. Okay, so here I have this u to the power 3. This is x. X is u to the power 3 plus 3. That's u. I have it here. This is x. It's u to the power 3 plus 3. Okay. This is x. And I have 2 here that you can see. So this is plus 2. I have 2. Oh, that's good. And these are the values in the numerator. Okay. And here, what we have in the denominator, we had u substitution. And this is u. Okay. This is u here. We have u. But this is the integral. I have to write it again because the integral was in the wrong place. Just a moment. So let me take the integral again. This is the integral. Do we have? Yes, I have integral now. Just a moment, and let us fix this first. This is better. Okay, now I can write this is x. I can write that this is x, okay, plus 2. This is x plus 2. You can see this is x plus 2. And here I have only u. Okay, you see that the integral sign is in the middle now, so it's okay. So, and I have dx at here, okay? So dx is this one, dx is this one, multiply 3. So I can copy it from here. This is dx. I can have it from here. Okay. So this one is dx. Okay. What I have here is that this one at the top. So it will be equal to integral. Let me take this stuff from here too. Okay. So I am going to have this stuff plus 5. Okay. And I am going to multiply by 3. So if I multiply by 3, this makes 3 and this makes 50. Okay. Then I am going to multiply by u to the power 2. Okay. So here, yes, I am going to multiply by u to the power 2. And this will make 5. And this will make u to the power 2. You can see it from here. Okay. So this is u to the power 2 here. Okay. So, but I have to divide with u, both of them, okay? And multiply by du. So this become like that. So equal to, again, this integral part. Okay, what it will be? I am going to divide each one by u, and this will be 4, and this will be 1. Only 1, u to the power 1, or sometimes you don't need to write it. And this will be 1 again. I divide it by u. All of them by u. Yes. Okay. So I can write here now. So equal to this, all equal to integral. Let me take integral again from here. This all equal to integral. This 3 u to the power 4, u to the power 4, 3 u to the power 3 u to the power 4. 3 multiply u to the power 4. Yes. And this is plus 15u. Okay, so we have 3 u to the power 4 plus 15u du. Okay, so you can either have a bracket here, or you can directly write du. Okay, this is du. Good. Now you are just going to take integral, and you can see the integral here, this part integral here. It is, you take the integral of this one, and it is 3 over 5 u to the power 5. And integral of this one is 15 over 2 u to the power 2. Because when you take integration, you add 1 here and you divide the power. Okay, and this makes after you find what are used here, you can substitute x again. Okay, so what was x? X was this one that you can see here, u to the power 3 plus 3. Okay, but here this was u. U was square root of root 3 of x minus 3. So here you write root 3. Root 3 means here, just a moment. Yes, here we have root 3. So what does root 3 mean? Root 3 means x minus 3. This is root. Okay, this one, x minus 3 root, this is root 3. I will come to here. Yes, this is root 3, and it equals to, just not it. This equals to x minus 3 to the power 1 over 2. This to the power, and this one is, sorry, 1 over 3. Okay, this is root 3. So if it is root 2, it is 1 over 2. This is root 3, so it is 1 over 3. So that's what it does here. Okay, so x minus 3 over 1 over 3. But we had also 5 here, so that makes 5 over 3. And here this is x minus 3, 1 over 3. And we also have 2 here, so that made 2 over 3. So this is our answer here for this question. Once again, what we did here, we have an integral question, and in this question we use u substitution. For that, we let u equals to square root of root 3 of x minus 3. Okay, we let u root 3 of x minus 3, and we find x, we solve for x. Okay, and we solve for dx, we solve for x, and we solve for dx, and then we have all u's here. We have all the variables as u. Okay, and we find integral in terms of u until the last step. We find integral in terms of u. Okay, this is the result of the integral of this equation here. This is the result of the integral of this equation here. All are in u, the variable u, and then we change variables again. We have, this is u, and we change it, and we substitute instead of u root 3 x minus 3 here, as you can see. Any questions until now? So we are having the second question here. This was the first question. Yes, this is the second question that we are going to solve. And you can see the root here. There's a root here, root question here. So we are going to use substitution. Okay? We are going to use u variable. It's not important whether we have u, a, b, c, whatever it is. We are just using a u variable. These are too small. Let me make them bigger. Okay. So you can see them here. Okay. So now this is square root. Okay. It's not root 3. This is square root here. So again, we say when we see a root question. Okay. We say that it is u. You can see. Okay. Let me delete this one here. Okay. So this is a question. This is a question, and this is the answer. Here you can see that we have variable u. Okay. We have this variable u, and we put here u. Now we have to find values of x. Okay, we have to find values of x. No, we have to find values of x. I am going to have some shapes insert. Shapes. This one. Okay. Yes. Yes. Let us continue from here. It's bigger in this way. So here we are using u substitution. This is u. Okay, we put here u, and we have to write this integral in terms of u. We don't want any x here. We want everything to be u. So that's why what we are doing, we are writing here, okay, this is u. So we are solving this for x. Okay, we are taking squares of both sides. We are taking squares of both sides here, and we have we have here x equals to we have here x equals to u square minus 10, and we have here dx equals to 2u du. Okay, we solve for x and we solve for the x. We want to have all this integral written in terms of u. We don't want any x here. We had one x here at this part, and where's my laser? No, I cannot find laser. Okay, we had one x here, as you can see, and we don't want this x, so we are going to write u square minus 10. Okay, you see that instead of this x, I'm taking arrows. Okay, instead of this x, I have here u square minus 10. This is instead of this x, I have u square minus 10. Okay, and this is how I do it. X equals to u square minus 10, because this is u substitution. Okay, and then I take du over dx. Okay, I find derivative of this u according to x, and this leads to this one. This is here like this. This is d wait here. Okay, the function here is the x function. Okay, the function here is the x function. So I can have here derivative of this. I can have derivative of this according to u, du. And this will lead to here, as you can see, this will be 2u. Okay, so I am going to take derivative of this one according to x. So I have a function x. Okay, I have a function x here, and it is written as u square minus 10, and I'm going to derivative of both sides here. So I will have this one as derivative of x, this function, derivative of this function according to this one, and it will be 2u. And here by cross multiplication I have dx equals to 2u du. And from here I have now x written as u, and I have now here you can see dx in terms of u, and I have square root in terms of u. And now when I substitute this one, this is u, and this here, this is 2u du is dx here, you see dx, and now this is what as I have here, x minus 3, this is u, okay, x minus 3, this is u, this one here, this one here is u. This all because I let it equal to u. So this is u. And x is u square minus 10. So first of all, I write u square minus 10. This is x. Okay? And I have 3 in front. I have 3 in front. So this is x square minus 10 minus 3u. So this all together made this. So this is just change of variables. This is I change variables. Okay. So let us continue from here. So you can see that slideshow. Okay. Yes, here. I'm going to delete this once. So what I have here? I have here 4u, okay, and this is in fact the roots of this one. U square minus 3u minus 10. Roots are minus 5 and minus 2. You remember how you find the roots here? I will open a new one, and here we have here, this is u square. This is u square, and that's minus 3u. This is u square minus 3u and minus 10. Okay, and you know that from the sum and product method, sum is minus 3 and product is minus 10. So we are thinking which two variables are when we multiply our product is 10, and when we subtract, when we add them, the sum is minus 3. So these variables are minus 5. These variables are 1, minus 5 and 2 variables. So these 2 variables, when I multiply this one, product is minus 10, and when I add them, sum is minus 3. So from this method, we find that this is u minus 5, okay, this is u minus 5 here, and this is u plus 2, okay. So this is just an equation, second order equation, and we solved it like this. Yes, for finding answer here, you see that we are using A and B. We are using an A and B.